master sets are, at least for the first several chapters, are from old tests. So this is one of the critical differences between them. So part of the master set is sort of forced studying. And so that is done, and then I'm assuming most people are going to write it out on paper, take a picture, hopefully put it into one document, and submit that. If you're not familiar with how to submit a document through Blackboard, then please ask. But it's relatively simple. If you click on Master Set 02, not the attachments. If you click on the attachments, then it'll pop up with the document, the question you're supposed to answer. But if you click on Master Set 02, then it'll take you through to a screen where it says Submit Assignment, and it allows you to attach a document if you want to. The textbook problems, obviously from the textbook, they are much simpler problems than the master set. And when it comes time to what I call the homework quiz. So in chapter 2, there are think and solve problems, think and rank, think and explain, and I think, there we go, think and discuss. There's 4 different types of categories that they've labeled. Some chapters will have an additional category called plug and chug, but this one has only 4 categories. Of the assigned problems, I'm going to take one of each type, put that on a paper. If there are any numbers involved, I feel free to change the numbers. I might add some wording for clarification, because sometimes the wording Hewitt gives allows for multiple answers, and based upon what I believe his intent was, I might tweak it a little bit. But that is going to be an in-class exercise. It's a quiz. So that is the difference in terms of grades. In terms of content, the textbook, a lot of it is just guessing basic concepts. Some of the master set are concept questions, some of the master set are more sophisticated than that. Yeah, I'd have to, I think it's as generalized as I can make it right there. Do you
No,
need
that
more
answered my
clarif-
question, that was perfect.
Okay.
Okay, and then, so when a master set is due next Tuesday the 18th. So
Yes.
can we expect a quiz that day too?
All right, so the quiz, I'm glad you brought that up. So in a normal, and I recognize this is a blended class, but in a normal all face-to-face class, when I'm finished with the material from chapter 2, I then say, all right, let's talk about when things are due. And so then I will announce when the homework quiz is. In a blended class, potentially you're finishing chapter 2 outside of class, considering 2/3 of class time is really online and not here. So what I'm sort of going to take an educated guess at the pace at which is reasonable for students. And so we'll say that the quiz, the homework quiz for chapter 2 is going to be a week from today. And so again, it's going to be 4 questions, because there are only 4 different types of problems in the textbook for chapter 2. And I'll take one of each type.
Alright. And then, sorry, one last question.
No need to apologize.
Oh my gosh, I just forgot. Oh, okay. So the videos you posted about chapter 2, I'm watching those and reading chapter 2. Is that too much, or is that what I'm supposed to be doing?
My ideal is that you read the chapter, you look at the commentary, where
I saw that. I printed that out actually. It's the wrong thing that you typed up, right?
Right.
Okay.
That, I think at this point I've changed all the wording. When I first came into this job, I sort of inherited a chapter commentary. And then I didn't like some of the wording, so I changed some of the wording, and I think at this point it's all in my words. However, I wouldn't be surprised if there were some sentences I just cut and paste from my predecessor. That is, the intent was that would be read, that would go in conjunction with the textbook. You finish the section, let me read the commentary on that section.
Okay.
That was my thinking.
Okay, no, that makes a lot of sense. Cause I was watching the videos you posted, and I'm guessing that's more for just your online classes. Cause most of what you said in the videos goes along with what you said in class.
Right, when I first started making some of those videos, I'm sitting in my office and I've just got a camera on me and I've got the really sophisticated special effects.
Gotcha.
That was for a hybrid class that I taught in summer of 2013, something like that. 2014, somewhere back then. So, yeah, that's where it started. And then pandemic made that expand rapidly with the number of videos out there. I had 96 videos in 2017. That's all. I have somewhere around 1,200 now. I think I answered your question, then I rambled.
No, you answered it.
Okay. Did you?
Okay, just because I just have a hard time using Blackboard, but, so I like read the commentary, I read the book and watch the videos and read the commentary.
Mm-hmm.
Okay.
Oh.
I have a hard time finding everything at sometimes.
Oh, okay.
But I found it.
All right. I tried to keep where everything is in the same place for each chapter, although like, yesterday I went into one of the later chapters and I realized, I had things in different order, so it's a work in progress.
No, it's really well organized.
Yeah.
It's just
a
what
lot.
am I
It's a
supposed
lot.
to do?
Yeah.
Like, it's a lot.
It's
so
hard to
they
narrow
get
down
used.
what's for
If I don't
us
watch the-
specifically,
Yeah,
and for the online, I think is
Yeah.
a big thing.
cause like if I don't watch the videos, well, am I gonna miss something?
Yeah.
That's not in the textbook? Does that make sense?
Yeah, and
Okay.
yes, you probably will.
Okay, so
That-
just do them both, basically.
Yeah, I would recommend both.
That's what I was worried about, was just missing information.
Okay, Jasmira?
So, how many hours would you consider we need to study for this class a week?
It depends on who you are. The generic student, it is a 2-to-1 ratio. You should expect to spend 2 hours out of class for every hour in class. I think that's 2-to-1 or 3-to-1?
3 to
3-to-1? And so this officially, in a normal 16, in a 16-week class, the class piece of it is 3 hours a week. So you'd expect to spend 12 hours, except for the fact that we're doing it in half the time. So it puts it around 24 hours. That is generic. You each know your own style. Each of you learns at a different pace. Each of you has a different background. So I've had some students struggle, barely squeak out a C, and other students spend very little time to make an A. And then the reverse. I've had students who really worked an incredible number of hours in the course, pulled out an A, and those who got overconfident and cocky should have done better and didn't. I'm not sure I could make that as generic or as vague as any more than that. I don't know if that helped or not.
It does, it's just because I know I had an anatomy class and she told us at least 3 hours a day, so I was just like, if you had a specific time, like, if I'm studying too long, if I'm studying not long enough, I just wanted to estimate, but you answered it. Based off of, yeah.
I suspect somewhere in early March, you'll finally figure out what the right ratio is supposed to be for you.
Okay.
I'm a little bit slower. In April, I'll figure out what the right pace would have been for this group. Any other questions at the moment?
I mean, if you're not in a rush to get started.
Let me close the door.
Okay.
Yeah, because
If it's a question about not yesterday, day before yesterday's lab, should we wait until the lab portion of class?
No, I really do view this as we got 3 hours to do what we want with it.
Okay, I just didn't wanna set you back. So I'm not tech savvy at all. I've
Sorry.
watched,
I want to cut you off right there for just a moment.
yes.
When I walk in here, there's certain things that I will do. If there are absolutely no questions, and I hope that's never the case, but there might be. If I walk in here and there are no questions, then there's a certain place I'm just gonna pick up. I'm not gonna pick up where I left off last time, because again, it's not a traditional class. I'm assuming that you've done some groundwork already. if I spend the entire 50 minutes answering questions, I'm fine with that too.
Okay,
So
well, that's good.
they'll never apologize for asking
I think I
questions.
have enough to actually fill it out.
Well, that's really good. So I'm not tech savvy. I've watched the videos, but I cannot for the life of me figure out how to, my axes are off. So like the information for my bounce height is on the drop height and my drop height is on the bounce height. And I cannot figure out how to, like I remember you like copied and pasted the information and put it somewhere, and I saw that in the video too, but I don't see that on here. And I was using the spreadsheet for a while, and then I realized that I do have access to Excel. And I've done this multiple times and I keep getting one. And you said we should not get one.
Yeah, we all got one in our group.
On one part, on the first series,
No.
but I feel like it's also because my information is wrong. Do you know?
I'm not sure how I can answer that without looking specifically at yours.
I have no idea how to even do that.
Yeah,
Yes,
and
Mira?
also when I put my information
Yeah,
on the sheet, for some reason I have to put, I don't know if it's just my computer, but you know how you said put the independent variables in the A column and the dependent variables in the B column.
That's the way I had it set up.
Yeah, mine is going straight across, but it looks like a graph.
All right, I'm gonna do hopefully a quick walk around and hoping that the solution's readily apparent. I'm wondering if.
Are you confused?
No, I suspect that these are easily solved problems. I'm trying to decide how much is class time and how much I can do right after class and right before lab.
Okay.
So I'm sort of leaning that way of, don't let me forget, but
Oh, okay.
ask. I think these are asked during lab time questions when I can talk to you individually.
Okay.
And if it turns out everybody's having the same problems, then I missed that one. But,
I think we are, well, we were a lab group, so I think we are.
okay, so 3 of you, all right. And it's possible that your data just happened to be that good?
I don't know.
Well, wait, you said 1, was it the slope was 1 or the R-squared value?
No,
was
the
one?
R squared is 1.
Well, I didn't get that right, I'm still on the.
Okay.
R squared is 1 for series, which one is it, 2?
No, it's 1.
It's
Maybe-
series 2, it's series 2, that's 1.
In
Yeah, it
physics,
is series 2.
always assume,
Or the second ball, sorry.
you're allowed to assume in physics that you are right and everyone else is wrong. So don't forget that.
But I'm stressed out.
Yeah.
We'll get it resolved.
Okay.
It's not like the lab's due today, at least I think that was probably a good call that we did.
Yeah, it is. No, yeah.
Okay.
This graph stresses me out.
And I understand, and my hope, and I think in a lot of cases, after you get the first one done, the rest of them will be, oh man, this is so easy, so much easier than doing it by hand.
Those are my problems.
But I can understand if you're used to doing graphs by hand or not doing graphs at all, the first one with Excel or whichever spreadsheet program you're using, there's a learning curve there.
For the first one.
So are both, what is it, is it supposed to be 2 on one graph, or is it supposed to be 2 separate graphs?
One graph, 2 lines, 2 sets of data, 2 lines. All right. And any other questions at the moment?
It's just it's backwards, this needs to be up here,
All right.
this needs to be over
There was something I forgot to do on Tuesday. There's the pre-course assessment. I would like to do that now. This particular question right here is the bowling ball falling out of the airplane question. About which way it will go. So the plane's going in one direction. I am assuming the bowling ball is just rolling out, that somehow maybe there's like tilt to it, someone puts a bowling ball on it, and then the bowling ball rolls out. I will be the airplane, this is the bowling ball. The plan is for it to leave my fingers at about this point right here. Now, I can try to roll it, so in other words, do something like that. But I'm just gonna drop it. Hopefully you will accept that as close enough. So when I get to here, so the question is, where does it actually hit when I let go? I need a running start without hurting myself. Did it land where I let go?
No,
No.
Where did it land?
I had it where you let it go,
Okay. Any other observation?
or like after.
It rolled.
Okay, more interested about where it actually hit than what happens after it hits the ground.
Didn't it hit behind where you let it go? So it moved to the left a little more?
It hit behind where I let go?
So like you dropped it and then it rolled forward more.
No, like as it was landing, it moved back.
I don't think it moved backwards. I let go of it somewhere around here and it ended up over there. But are you saying that I let go and it hit over here and then rolled that way? Some sort of backspin on it? Well, let's take a look again. Now, obviously, not everyone has the same viewpoint, and people watching the video of this won't be able to see any of it at all, except for me running into it or past it. Good viewing. I guess this group right here is the best viewpoint. If you wish to move so that you can see it, feel free to move. All right. So did it land, where did it, I let go of it somewhere around here. Where did it land?
There.
Over there.
Now I think A has it landing behind. B, it falls straight down. What's an explanation for its landing over here?
Because it was moving at the constant speed as you were until you dropped it, so it took a second for the other forces to slow it down.
What other forces would slow it down?
Air resistance.
Okay. Typically in this class, we ignore that. But yes, air resistance would slow it down. Would slow it down? Gravitational force definitely has an effect on it, otherwise it wouldn't fall at all. There's no gravitational force on it, as soon as I let go, it would just basically hover right there. Actually, no, it wouldn't hover right there, it would cruise along like that.
You stopped putting your force on it?
I did stop putting my force on it, that's why it fell.
Does the airplane have something to do with it?
Yeah, it's possible the question's already been answered. So, how fast, airplanes go 500 miles an hour? Ish. When the bowling ball leaves the airplane, how fast is it going relative to the ground?
Miles per hour.
Ish. Now it's rolling backwards, so maybe 499 miles an hour that way, the same direction as the plane. That bowling ball has quite a lot of speed when it comes out of the plane, and that is taken into account. Now, once it's released, what's going to happen to it? Well, it is going to get faster as it falls. And so it starts out falling slowly and then gets faster and faster as it goes. And we'll cover that that's a chapter 10 officially, but yes, Jasmira.
So the wind wouldn't have an effect on it even from the pressure of the wind in the bowling ball?
It would have an effect, but we would have to assume that the wind is not going to blow it backwards. All the wind's going to do, air resistance basically slows it down in this particular case. And so without air resistance, it might fall like that. With air resistance, it would fall more like that. Some of those details will come out as we do chapter 3 and chapter 10. I was thinking there were some of them where they specifically say ignore the effects of air. Not on that one. The other one that I find interesting is the first one. Two metal balls are the same size, but one weighs twice as much as the other. So I need two objects that are roughly the same size. These are approximately the same size. This is steel, this is aluminum. So their weights are very different, their masses are very different. If I let go of them at the same time, which is going to hit the ground first? So we got a couple same times, got a heavier one. And you said heavier?
Same time.
Same time? Let's find out. Just so you're trusting my reflexes less, that I can let go at the same time, all I'm gonna do is I'm gonna just jerk the notebook downwards. And you know what? You got the view last time. Over here, all right. That side over there, if you can't see it, you're gonna have to sort of listen for it. Or move. Did it sound like they hit at the same time, or did the heavier one hit first? They should hit it at the same time. The steel one, actually considering the rust is probably closer to iron than just plain steel. The iron one weighs more, which means there's more gravitational pull on it. There's more mass, which means that it's harder to move. And it all balances out in the end. So they should hit at the same time. All right. Any questions before I talk about lab? Oh, percent error, that's right. Well, that relates to lab, so let's talk about percent error. Oh. Course entry assignment. Most of you, I think there's only one person who hasn't started it for the class. And the lab, about half of you haven't done it. The lab one is it's a one question one. The answer's right there. The answer is 42 in case you miss it. Unless I asked a different question. It was the 42 question, right? Yeah, okay, the answer's 42. Anyone understand what the reference is? Absolutely.
Tell us what? I didn't hear.
Hitchhiker's Guide to the Galaxy.
Guardians of the Galaxy.
No,
Hitchhiker's Guide to the Galaxy.
Oh.
by Doug Adams. So anyway, the answer is 42. You'll spend more time clicking than you will actually thinking. So, but the powers that be want this done. It's just saves a lot of hassle if you just do it before the end of the day. All right, throughout this course, there are a couple things that will keep popping up. One is doing graphs. One of them is percent error and percent difference. Some of you will struggle back and forth trying to remember which one's which. It happens. If you have to ask every time, ask every time. So ultimately, you have an answer. The question is, how far off are you? And the other question is, do you know what you're comparing it to what you're comparing it? If you are finding percent error, that means that there's something wrong. That means that you know what the correct answer is. So you're going to, in percent error, you're going to compare to the correct answer. And sometimes there's a very blatant correct answer. For instance, if we did a lab on finding circumference of round objects and the diameter, and looking at the ratio, the slope should be pi. In this one, it's a little bit more nebulous. But for percent error, you basically are comparing two numbers, and whatever the difference is, that's the numerator. So the delta just means change. So this is the difference. So if I have, I expect the answer to be 14, and I get, so my experimental is 15, the difference is 1, and then I divide by to what I'm comparing it to. Since I have an expectation of 14, I compare it to 14. I'm gonna 0.07-ish, I think. Yeah. 0.07, and then put it in percent form, multiply times 100%. Or you multiply times 100, and you get 7%. So this would have a percent error of 7%. That's the one that you're doing for this lab. Now in this, or sorry, in the lab that you did 2 days ago, that's due next Tuesday. That lab, you have one experimental answer. I mean, you drop the ball and you see how high it bounces up for part C. That is your experimental. The purpose, a lot of times when doing graphs, is that you assume that if you got a set of data points, that some of the data points are off in one direction, others are off in another direction. If I'm statistically, I'll have just as many points too high as too low from what the correct answer is. So the assumption is if you do enough data points, and so at this point there are 5 data points you're plotting to get your graph, we're assuming that this line is actually correct. That is the assumption. Because we have nothing else to base what the actual answer is. So your prediction that comes from the graph, from the equation for this line, or from the line itself, that is what the expectation is, and so that's what you're going to compare against. So if it bounced up to 130 centimeters, so that was your experimental, and from this, the prediction was 140 centimeters, then the percent error is the difference between the two, divided by the prediction, which is, well, the same ratio. If you'll notice in the labs on the table, I had units in parentheses. For the graphs that I've seen units in parentheses, which they should be. And if the units are in parentheses, you don't need to rewrite the units. For whatever deep psychological scars from my youth, whenever I ask for percent error or percent difference, I do not have percent in parentheses. So you need to put in the parentheses. So 7% would be proper.
So the prediction is always going to be in the denominator, and then the difference, whether it's positive or negative, will be in the numerator, no matter if it's positive or negative.
Right, okay, so in terms of positive or negative, there are some instructors who actually specify it of which one you're subtracting from which one, and then the answer is positive or negative depending upon, but the positive or negative answer tells the instructor something. There are many things I'm really picky about, that's not one of them. So just subtract the smaller from the larger, just make it a positive value. If you give me a negative value, I don't take off for that. And hopefully I answered your question on percent error. Any other questions about percent error? Percent difference is, I have 2 answers. I found the value, I go through some calculations and I come out with one answer, and one answer is 20, and I do it a completely different way and I come out with 19. They're both found experimentally. There's no theoretical aspect to it. I have 2 numbers and I need to somehow compare them. Since I don't know what the right answer is now, I can't find an error. I don't know if there's an error or not. This is when I find percent difference. And so in that case, you take the difference, which in this case would be 1, divided by the average of the 2. So we don't know what the right answer is, but we're just going to assume the right answer is the average of them. So you divide by the average of these 2 numbers. And that's 5-point-something%. on the lab part of Blackboard, under coursework, labs, there should be some, something labeled lab manuals, where there's some documents where it talks about this.
Is the one representative of the difference between 20 and 19?
Yes, yes, it's not, I guess, let's make it 18. If you've already written down 19, that's fine too, then that would be 2 there.
Thank you.
All right, other questions right now? All right, so let's talk about the lab. How many of you have worked with a lab quest before? All right. The lab quests come in these boxes right here. It looks like this. Like this. There are sensors that come along with it. The 4 sensors plug into the ends here, which is usually really convenient. Those are the obvious ports. There are some other labs we'll do later, and there's 2 ports underneath, like this, that sometimes will be used, but not today. All right, so you have there's 2 parts of the setup, but several parts of the setup. So the first part, when you're finding the mass of the meter stick, determining the center of gravity of the meter stick, you're gonna use a triple beam balance. The triple beam balances are back there. I'm assuming enough people have used triple beam balance before, and if not, just call me over and I'll be glad to show you how to use it if you can't figure it out. So that will get you the mass of it. You just take the meter stick without this on it. This is removed. Taking it too much. So you put the meter stick on it and get the mass. The mass, I think the lowest mass I've seen legitimately was somewhere around 50 grams or 0.05 kilograms. And I think there's one about 1.5 kilograms. Most of them are somewhere 0.15 kilograms. I don't know if I misspoke just then. Good thing I moved the camera just in time to walk away from it. To find the center of mass, this is the fulcrum holder. This is the fulcrum. The fulcrums can be found in the Avaya box down here. So what you're going to do is you're going to try to balance it on here. Now there are 2 ways I can balance it. I can balance it like this or with the knob down. Knob down, please. Knob up is a path to insanity. It can be done, but if you're just a little bit off, that thing's going to make it keep going. And the level of precision that we need for this lab, that's fine. So you put it on here, orient it correctly, so that it can rock back and forth. Now obviously, this is not the center of mass, so I need to move it that way. So I loosen it up, move it. Closer. And the excitement of this. Now, on this lab, there are a couple of labs where being incredibly retentive about the work pays off. So you want to get it as horizontal as possible. However, you might get run into a situation where you have it clamped down and you don't have to really tighten the screw, just enough until you feel a little resistance. You have it tightened up, it's leaning one way, you move it 1 millimeter over and suddenly it's leaning the other way. When you get into that situation, pick the middle of those or somehow agree upon which millimeter you're going to round off to. Again, trying to avoid the madness. Now to actually read it, you got a little notch right there in the middle, kind of like a widow's peak. Right there, that's the number that you're gonna be reading off of it. That's where the center of gravity or center of mass is for the meter stick. So for this particular one, it's like 49, slightly more than 49.5 the way I'm reading it. 49.51 centimeters. And I forget if I asked you to do centimeters or meters for that. Centimeters, okay. Then you're using the same meter stick. Now, for demonstration purposes, this is a different meter stick, but if I were doing the lab, I would then take this off and I would use this meter stick here. This is the basic setup. Now, I think I specify where I want the force sensors to be in terms of getting the best results. You want the meter stick to be as horizontal as possible. Now, right now, this is obviously not horizontal. The simplest way of fixing that is to adjust the height here. Now, how do you know when it's horizontal? I think a number of people have a pretty good sense of if it looks horizontal or not, but you may assume that the mortar in the walls, the stuff that's horizontal, is true horizontal. So you can eyeball it against the lines around the room. We do have a level up there. I don't think the level really works as well as eyeballing it against the mortar. And so the side seems still too high. So you want that horizontal. Ideally, these are vertical, or as vertical as you can get it. So right now, this is leaning off towards that way. Scooch that over, and that's looking close enough, and this side is still too high. That wouldn't have changed. Does it seem horizontal?
Too low.
All right. Say when.
There's the-
Right there.
Now, when I tighten it, it adjusts a little bit, but I'm gonna pretend that's horizontal for, again, demonstration purposes. So, I have my two force sensors plugged into my LabQuest. Now, since none of you have used the LabQuest before, they don't hold a charge worth a darn. Now, I'll pick this one because it actually does have some charge in it. But if you need an extension cord, there's this extension cord down here, which is plugged in all the time, and then the extension cords on the top of this bookshelf over here. When you're done, please make sure you unplug those and put those extension cords back. Those are older, and yeah, I think some of those extension cords I had when I was young, so there's an age on some of them, I believe. Now right now, the force sensor says that one of them is telling me the one in port 1, channel 1, which is this one, is registering a force of negative 12 newtons. The other one is registering a force of positive 0.59 newtons. Well, there's two things wrong there. One, that would imply that the total weight of this object, of the meter stick, is somewhere around 12 newtons, and I will guarantee you it doesn't weigh that much. And it also has some different signs. One's positive, one's negative. Now the signs here are indication of direction. So one of the force scales is not pushing up and the other one's not, with the other one pushing down. Both force sensors are holding it up. They're applying a force upwards. So the reason why they're off is because they did not zero it. Now most of them have a stylus here, which you would use for actually touching the screen. Fingers work fine, unless you've got sharp dagger nails, then don't mess with the screen. Some people will use the sharp side of a pen, no. Mechanical pencils, no. Stylus really is the best thing, but the finger will work, or erasers would work too. All right, so to zero it, first off, I want to zero it when the meter stick's not on it. Since you're going to be zeroing it regularly, you don't have to take the meter stick all the way off, just make sure that the strings are not pushing down on it or pulling on it. And so I just clicked on the value there, and then I hit the word 0, and it's now 0. The other one I do the same. And then I can put it back down. And one of those force sensors is not working. And that's also part of this lab, is when you find out the equipment's not working. Oh, that's full. Well, unless I got really unlucky there. I think that's a LabQuest issue, not a force sensor issue. Anyway, the gist of what's supposed to be done, obviously you need to retire this force sensor. Or this LabQuest. Alright, that's the setup. We have 4 sensors back there, you'll need 2 of them. And LabQuests are up here, don't take this one. And I think with that, I'm picturing, I think we have 15 in here right now. 5 groups of 3. I will grab the face shields, and as always, rejoice, because this is physics.